Today we'll talk about AI, user-owned AI agents. Does AI work for you, and how can we ensure that this actually happens? For that, we got David on the show today, co-founder of Lit Protocol.
Where do you manage the secrets in the context of software is a generational problem. For decades, software developers have said, okay, cool. And where do we put the keys? The fundamental purpose of Lit Protocol is to secure and make secrets programmable through a decentralized network.
Perhaps can you give us an idea of some of the use cases?
Three main categories: bridging and interoperability, encrypting the private data, using Lit for agent wallets and user-controlled AI. If you're going to have a piece of software like an AI or an LLM that is performing actions, where do you store the key pair for that interaction?
Hey, Sohail here. Thanks for tuning in. Real quick before we begin, if you enjoyed this episode, if you learned something, please consider to follow or subscribe or share this episode. That helps us out a lot. It helps us to reach more people and to spread quality education across the space about crypto and Web3. Also, if you're part of a crypto project or represent one and you would like to come on the show or do sponsoring, please get in touch with us. And lastly, everything we talk about today is for educational purposes and no financial advice. Enjoy the show. Thank you for tuning into another episode of the TEACHMEDEFI podcast. Today we'll talk about AI, more specifically about agents, user-owned AI agents, and the theme of does AI actually work for you, and how can we ensure that this actually happens? For that, we got David on the show today, co-founder of Lit Protocol. Hey man, thank you for coming on the show.
Thanks so much for having me. It's a delight to be here.
Yeah, same. Lovely to have you here. I mean, these are all very timely topics. I think crypto and AI is one of the big verticals that people in the space are talking about at the moment. So perhaps, actually, I came across Lit Protocol before, and I had a project on that you might be familiar with, which was Genius. I think they use your infra.
Yes, you know them well.
That's interesting. So I've heard a little bit about what you guys do around like multi-party computation and that stuff, but if you just want to take us start off and give us an idea about Lit Protocol and what it is you guys are doing.
Yeah, absolutely. So we've been developing this network for a little over 4 years. And in October of last year, we launched the Mainnet beta. The network currently manages about $160 million, and largely for facilitating bridging operations like what Genius is using Lit for, and a number of other teams, and also securing private data. And so both of those things are anchored in the fundamental purpose of Lit Protocol, which is to secure and make secrets programmable through a decentralized network. And so just to add a little bit of color here, this idea of where do you manage the secrets in the context of software? We could talk about like what secrets are and why they're important, especially related to the AI era. Is a generational problem. For decades, software developers have said, okay, cool. And where do we put the keys, or where do we put the secrets, which are synonyms here? And so, yeah, we've kind of over the past several years have taken this core problem and had the insight to say, well, what if we take this problem and turn it into a capability and a capacity for developers? So at the most fundamental level, what Lit Protocol is a method for developers to write programs where the outcome of those programs is some signature or some decryption or some use of a secret.
I get you. Okay. So can you break this down a little more? So how does multi-party computation kind of hook into this?
Yeah. So, if we think about like Vitalik's big insight with Ethereum, is first there was Bitcoin, and then setting up a network to manage state. It's a lot of work. There's a lot of overhead. Vitalik's insight was to put the smart contract layer on top such that people could program the state without having to set up the nodes. We've gone through a similar process, but in the context of secrets. So from somebody who's building a product and interacts with this protocol, they're programming the secrets. But underneath that system is a multi-party computation threshold secret scheme, which is a fancy term to say taking a key and dividing it up into fragments that are represented on a T of n basis. Is how it's typically described, like 8 of 12. So there's 12 node operators, for example, and 8 of those parties need to authorize any given use of the underlying secret. And then as an additional security layer, all of these nodes run inside something called a TEE. And so that's the security model of lit is break the key up into parts through MPC or threshold cryptography and then operate over those parts inside of a black box secure hardware.
Right. I was talking to a friend recently about the term black box when you refer to trusted execution environments. And I was like, I don't like the term black box. It sounds like something ominous is going on, or you don't know what's going on. So we settled on the term secure box.
Good.
But regardless of that, before we talk about TEEs and how you're using that, perhaps can you give us an idea of some of the use cases that would use your infra there?
Yeah, absolutely. So there's three main categories. The first is bridging, like we talked about. Teams like Eco, Genius, Emblem Vault use Lit to essentially program accounts across a variety of blockchains, such that you can do things like swaps from one chain to another, independent of the VM. So, like Bitcoin to Solana, Ethereum to Move, any permutation essentially instantly because instead of bridging, you're just holding liquidity or assets on multiple chains via this programmable account, aka programmable key, aka programmable secret, what lit is. So, yeah, bridging and interoperability is the first category. The second category is private data. Um, Most of the major data marketplaces like Streamer and the work from Fox, they have a product called Verify, which is a media data marketplace. They use the lit key for encrypting the private data. Because if you're going to store data on a system like Arweave or IPFS or Recall, a public network, it needs to be encrypted if you want it to be private. And then the third is related to what you kind of introduced at the top of this show is using Lit for agent wallets and user controlled AI. And so the fundamental question there is if you're going to have a piece of software like an AI or an LLM that is performing actions like buying tokens, using DoorDash, doing e commerce, buying stocks, whatever it might be, while the human being is not clicking the button, is not at their computer, what we would call as human out of the loop, where do you store the key pair for that interaction? And it's really interesting if we kind of like think about this from a high level. In all cases in software, identity and authority of an individual is represented by a secret. In blockchains, it's the private key. In e-commerce, it's a credit card number. For the New York Stock Exchange, it's an API key, and so on. And so Lit is set up to manage and orchestrate arbitrary secrets without exposing that secret to the edge or to the LLM.
Okay. So why use trusted execution environments as well? Then is so just for users or listeners that aren't familiar with TEs, that's a secure hardware element, right, on GPUs or CPUs. So even the person running the CPU, GPU cannot like look into it and see what code is running there. And I assume you use TEs then to have those key pairs on there and orchestrate it from there, or what does it look like?
Yeah, it's a great question. So, key management is serious business. Like the number one goal of our project is keep key material safe. And so what has emerged from that underlying intention is a defense in depth design that uses threshold cryptography and TEEs in a stack. So just to
Mhm.
look at these technologies independently, the great part about threshold cryptography is you can take a key and it's created in parts or these fragments, this T of n setup that we talked about earlier. But the issue is collusion. If you have 50 node operators and you have a 40 of 50 threshold, and those 40 parties come together and say, let's steal the key, all I have to do is put those parts together. So, the benefit is divided up into parts. The negative with threshold cryptography is collusion is possible. Now, to look at TEEs independently, the great benefit of a TE is it's a secure box. It can be set up such that nobody can get inside of it. But the issue with storing an entire key pair or an entire secret on a single TEE is if that TEE goes down, either because there was some kind of malicious intent, a bug, a solar flare, there's a number of reasons why it could go down momentarily or in perpetuity, you lose that secret. So, which is to say that the drawback of a TEE by itself is that you have a lot of dependence on a single computer or a single box. And so you put these things together, um, you end up with a situation where the total is greater than the sum of the parts, which is to say, uh, the benefits of both of these technologies in a stack benefit one another. The TEE prevents the collusion of the threshold cryptography, and the threshold cryptography prevents the dependence on a single TEE box. So there's a very kind of harmonious and reciprocal relationship with these two fundamental privacy enhancing technologies that are like the two core capacities of lit protocol security.
Is it a CPU TE?
Yes,
All right. Yeah, the person running TE, the component, the part of the key is not exposed to that person because it's on the trusted execution environment, so he does not know what it is.
that's right. And then because of the uh, threshold aspect of this, so if you have 30 nodes and a threshold of 20, and something happens at some data center, the power goes out, and you lose two of those nodes, the service remains totally uninterrupted because of the fault tolerance built in with the threshold.
Okay, gotcha. And so, how do the machines holding the parts of the keys know what to sign and what not to sign?
Yeah, so we wrote an operating system for the TEE, and uh, they do things like checking authentication, verifying user signatures, all that kind of thing. But for more sophisticated operations, because again, kind of going back to the Ethereum or smart contract blockchain as a metaphor here, the way that teams program lit is they write up a bunch of JavaScript that they want to execute whatever logic they have for the key material. And then that gets stored on an IPFS CID or content ID, which is an immutable address on the decentralized web. And so when a user says, "Hey, lit protocol, please perform some operation," they make a one to many connection to all of the nodes. The nodes then grab that logic from Filecoin or IPFS and run that immutable logic. And so the outcome of this is you have the same properties of a smart contract, which is it can be made immutable or updatable depending on how the logic is articulated, but where the outcome is some signature or a decryption.
Okay, so there's some rules defined on what can happen then, and if that user is allowed to do that action, and then this is executed.
That's right. And what's cool in the kind of comparing this to smart contracts system is smart contracts largely are isolated to the single island of a blockchain or a blockchain ecosystem, depending on interoperability. Um, this system with Lit Protocol can reach out to any website, any API, touch any blockchain. So it doesn't have the same kind of constraints that you would have in a smart contract. And granted, the outcome could be the same thing, which is some state change. But in the context of a smart contract, it's programming the state on a given blockchain. In the context of Lit Protocol, the outcome is a signature. Hence, all of the use of this system for cross-chain interoperability and multi-chain agents.
Ah, so you could sign some transaction on a different chain, for example.
Yeah, like I'll give you an example. A really cool team that's been building on Lit. I won't mention their name yet because they haven't launched yet, but is essentially rebuilding what Celsius had made, if you remember that from a few years ago, but fully with decentralized web technologies, where the user sends their Bitcoin on the Bitcoin base chain to a lit key, a Bitcoin account, a public address. That key material then writes to an Ethereum chain and says collateral secured. And now the user can take a loan out against that Bitcoin. And if they don't pay their loan back and need to be liquidated based on the rules of the system, the liquidation happens on the Bitcoin base chain. And so one of the interesting benefits here is that this is a method for somebody to take a loan out against Bitcoin without bridging, which has a number of kind of economic advantages for the owner of that asset.
Mm. And when you do that, you sort of take up the security assumptions of the lit protocol coupled with the trusted execution environments, eh?
Yeah, the kind of defense in depth of running threshold MPC in the TEE. That's right. That's the assumption.
And thus far, have you seen any security breaches that were of consequence? Or
No, I mean this system is like deeply thoroughly audited. That's one of our largest expenses outside of development is auditing. But it is interesting to kind of like say, what would it take to break this system? So the nodes that are running in the system, they do a key refresh every 30 minutes. And where these key fragments are stored is in globally distributed data centers. So if one did want to attempt to break this system, how they would go about it is they would have to do simultaneous break and enter in across like globally distributed data centers that have armed guards and stuff like that, perform a deeply sophisticated hardware attack on the box, and do that in many places within a 30-minute window.
that's interesting the way you put this now with the 30-minute window. Yeah, I was not aware of this. Okay. So can you tell me a bit more about the AI, let's say AI agent use cases that you're excited about leveraging this? And if there's already some stuff deployed, just feel free to tell us a bit more on that front.
Yeah, absolutely. I mean, first, I think it makes sense to kind of like set a little bit of context of where we're at with AI. There's a term that has been kind of rumbling around in my head, the commercial singularity. People talk often about like the singularity and AGI and when the LLMs will be able to create their next version. And that's a super fun and super important conversation. But it's my belief that there's a moment that will come before that where the LLM can transact just as accurately as a human can. And we haven't quite hit that moment yet. You know, if you were going to say, hey, agent, please order me a pizza, or please set up some dollar cost averaging based on these conditions, whether it's crypto or e-commerce, whatever it might be. Right now, the LLMs are like 85, 90% accurate. A year or two ago, they were about 30% accurate. And so we haven't quite hit that moment yet where they can perform the operations as accurately or better than individuals. So there are a number of really cool projects out there. Emblem Vault is one. Dexfin is another that are essentially like LLM interfaces for trading. And then another big part of this is basically having all of the tooling in place for that moment when we kind of cross into the commercial singularity, which probably 6 to 18 months from now. And then the other work that we've been doing here is um, we have a product coming out. It'll probably be out by the time this show is released, but this coming Friday, called Vincent. And it's a open source framework to build a personal advocate. And essentially the way that we are viewing the future is that there's the user who can be an individual or a business. And then there's this middle layer, which I'll talk a little bit more about. And then there's the rest of the internet, all of the services and applications that exist. And in that middle layer, where the secrets are managed, basically see that as an opportunity, like for the first time in decades on the internet, to have real individual sovereignty for a user, where there's an LLM that is acting on their behalf, that is controlling delegations to various agents. So this is just a screenshot, but this is an example of like an arbitrary agent runtime, in this case, doing DCA on Uniswap. And what we're talking about here is where the user would say, this agent can use Uniswap on base with a daily spending limit of $1,000. And so these
Mhm.
rules are totally customizable and can be verified because they're all open source on a per app basis. And functionally, what we're looking at here is something quite similar to OAuth. If you've ever like logged in with Google, you've seen that screen that says this app wants access to your contacts and calendar. You go, okay, that sounds good. I need to use that for this app. That exact same kind of mental model, but for assets and spending capability.
Mm. How do you, because you kind of talked about this already, to some extent, you can't rely on agents yet to do the work right. So to kind of have credible expectations right now that they will um, carry out the work the way you intend them to do it. So how do you think about this, and then kind of tra- traversing like a balancing act of how much commercial trust should you put in an agent right now, and how much is safe, how much isn't?
Yeah, I mean, the model that we just looked at is all around guardrails. I think guardrails are important even in a fully realized agent world, because we could have the best agent technology, but the notion of security is you have to look at the weakest link. Like, oh, can the developer get in there? Is there a middleman opportunity for somebody to say to intercept your request for your agent and divert your funds to themselves? Um, and so, like, the team at Signal, for example, has put out a bunch of content about this around how we need to completely rethink authentication and security for the agent era as we move away from the classic situation that we're all used to, which is like you have a phone, and on that phone, there's a bunch of services that are called apps, to a world where apps kind of disappear and you have a single interface where you say, hey, here's what I need, or here's what I'd like to do. And then you have some agent that figures out what's the right service to complete that intent or that request. And so, yeah, the idea that we've been building with is being able to have on-chain guardrails such that when a LLM says like, "Hey, buy 1 Bitcoin," or "buy flowers for my mom," or whatever it might be, instead of that LLM, whether it's closed, open, verifiable, instead of that LLM having access to the credit cards and the private keys, it sends the order to the secret management network, which is specifically built to check against the chain for policies, what we just looked at in the last screenshot, ahead of crafting the transaction and executing it to blockchain or posting a tweet or buying stock on the New York Stock Exchange.
Interesting. This sounds exciting. Where are you running the inference for the LLMs?
Yeah, I mean, this was pretty interesting about the system that we've set up is like this is just the auth. This is that middle layer where the user connects to the swarm. So, like, we built some example agents, but largely we've seen like the ecosystem of agent builders leveraging this system to say, how can I have a trustful relationship with the user whereby they're not giving me the keys to the castle, the private key. Um, and also I still have some authority to, as an agent developer, to make transactions on their behalf.
So you could build an agent on any stack and run inference wherever. It can be like a closed source LLM or open source LLM, but they can then make a call to the lit network, so to say.
That's exactly right. That's exactly right. And like, as we kind of zoom out, maybe let's call it 24 months and think about where does this all land? Like the 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 current view is that Apple and Google certainly will have their plays in terms of the home core assistant of where you can build agents. And those are largely closed ecosystems. They follow the app paradigm. There's baked in economic models like Apple's 30% cut on transactions. And what we're proposing with this is a totally open system. In addition to things being like having more capacity for developers, um, and it running on crypto rails, it's my personal belief that it is only through an open system that like as a society, as a species, as a planet, we will get the most beautiful outcome of artificial intelligence and LLMs, which are things like collective intelligence, global cybersecurity threat detection, these really sci-fi outcomes of intelligent services and protocols that can work for everybody and can serve everybody, but in a way are owned by nobody. Not too dissimilar to how the internet works today. And I think we really are standing at a crossroads right now where we either end up in a kind of siloed world, not too dissimilar to how Web 2 works, or this open alternative where there are different types of products that are like absolutely societal upgrades that it's very hard to imagine how they get built in the context of a closed source ecosystem or on like captured rails versus running on crypto. And I think another kind of interesting thing here to note is that as we built this system out, what we just looked at, we call it Vincent, as in Vincent the assistant. Um, there's a few interesting things to note. One is that we've built it in such a way that a transaction for an agent, whether it is on Solana, Bitcoin, Ethereum, Visa, Stripe, Shopify, the New York Stock Exchange, feels as similar as possible to the agent. Because from the LLM's perspective, these are all just tools, and we kind of think about this as like ratcheting up the abstraction stack. Web 2 has done this for decades, making it easier and easier and easier to build an app. And the more complexity that we can abstract away or hide beneath the surface for somebody who's developing an agent that they want to transact, um, the more likely we are to get to some of those really beautiful outcomes.
Mm, love it. Okay, open source the way to go. Echoing a lot of the Web3 ethos. So let's say you have an app, LLM, and you want to hook into it some agentic capabilities. So not just an LLM that responds to user queries, but also that can execute securely some actions for them. Is that a use case where one could implement lit?
That's it exactly. Yeah, we've seen teams already building things like impermanent loss prevention for LP positions, dollar cost averaging, some simple chart trading, hooking up to external data sources like what are the undervalued token or stock assets based on PE ratios, and automating DCA or dollar cost averaging into that. And so it's very much at the beginning of this era in terms of moving from LLMs that deliver information, which is largely where we've been for the past 2.5 years, basically since the launch of uh, GPT-3, to this next wave of agents that do things on behalf of somebody and like go beyond just a replacement for Google, but become an assistant and kind of have like a more material impact beyond information in terms of helping to structure somebody's life.
Mm. So talking to the AI, I could be like, okay, go ahead, find some stocks that are undervalued based on PE ratios and invest for me. And it could do
Exactly.
that. Okay.
And then where it gets really kind of wild, just to speculate on it a little bit, is right now, for lack of a better metaphor, users are largely naked when they interact with services. They automatically accept the terms and conditions. Um, they take the price that is offered when you buy software. Like consumers have no capacity, largely as individuals, to negotiate with any services. It's totally a seller's market, and people just have to take it. This is maybe a little bit more far out there, but I don't think it's too hard to imagine a future where every economic interaction there is a conversation between the buyer's agent and the seller's agent, where the buyer's agent is aware of actually what is that user's demand, how interested they are in substitutes, etc. And the seller's agent is interest knows things about the supply, of whatever they're selling, knows other information about the market. And you can almost imagine a more efficient economy where at every single transaction, rather than just being like, well, this kind of seems like where supply meets demand, there's a real time intelligent negotiation and conversation in the context of every type of transaction. I think it'll take some years to get there, but that's the direction that we're headed in, especially with our work around Vincent and designing this kind of personal advocate, the intelligent layer between an individual and a business and the world of services.
Mm. Yeah, but let's play it out and look into the future. What will kind of an AI agentic internet look like? Because will we not go on websites anymore? Are we just interfacing with the LLM and the agent does whatever we want?
Yeah, I mean, I think people will still go on websites to look at pictures and read things, but maybe reading happens through the LLM interface. Largely we've talked a lot about trading, but there's also a whole world where these tools can be used for creators. Let me give you an example of a prompt. Let's say you go to your agent and you say, "Hey, I've been talking to you for 6 months. You're broadly aware of my worldview. Please do the following: set up a newsletter, mint a token, set it up such that people have to stake the token to read my newsletter, read the news every day. At 9 a.m. my time, send me an email where you ask 3 clarifying questions from the news of the previous day where I respond to you. After I respond to you, publish my daily newsletter." Like, we've just established a media business in 5 minutes that somebody's taking 3 to 5 minutes a day to interact with, and they've now just like generated potentially sustainable revenue for themselves, in terms of supporting their lifestyle. And so I think we'll start to see a lot more of these types of things. We've seen this in Web 2 a little bit, where the agents broadly today are like customer service agents and sales agents. Um, but it's my belief that that will move closer and closer and closer to individuals, especially unlocked by secret management, being able to allow that agent to use the newsletter platform, to use the cryptocurrency address, to use the Twitter account.
I'm curious. It sounds to me like it, but curious to hear it from you. So, do you see AI and agents as a form of making us more productive and us still, or even being able to focus more on, let's say, the inspiration phase of endeavors versus the perspiration phase? Or do you see agents and AI as a means of replacing humans in some way, which a lot of people are afraid of?
It's a good question. I think it depends on what time scale. Like, in the near term, I largely think about agents essentially as replacements for apps. They're services at the end of the day. There's, things where human beings either had to pay attention to or think about or click buttons that now the agent can do in an automated and intelligent way. Um, but on a longer time scale, I think it will depend on, like, do we keep marching up the exponential curve from general intelligence to super intelligence to whatever is beyond that? Um, but yeah, these are the times right now for sure, where those questions will start to unfold.
Yeah. What do you think about vibe coding?
I think it's awesome. Yeah, we use a lot of LLMs, obviously, like always checking the work, in building out not the low level cryptography stuff. The LLMs aren't really good at that, but the things that are closer to developers and closer to users.
Gotcha. So I've been hearing a little bit about some other announcements that you have, I think, in the coming days, but I think by the time we publish this episode, it'll be already out. So yeah, do you want to share a bit about, I think, about your mainnet?
Yeah, absolutely. So the mainnet is scheduled for the third week of April. And ahead of that, we are doing, starting March 23rd, we are doing a community sale via this platform called Legion. Legion.cc is the website. And just really, really excited about, where things have unfolded as it relates to community sales and moving away from the dominant VC model of the past several years, and being able to work with people who like get and understand this, but don't have their full-time job as crypto investing into the project early and to become early community members. Um, so yeah, that's the big announcement that should be out by the time this gets published is that ongoing community sale. And um, it's really good. I think it gets back to some of what was so fun about the 2017 and 2018 era, but not with vaporware, right? Like with actual products that have product market fit and hundreds of teams developing on it and hundreds of millions of dollars managed in the system.
Yeah, yeah, I like it. That makes sense. I've heard a little bit about Legion, but I also heard that there's a bit of mechanics around it which are interesting around merit-based access. Because I think one of the things you have to think about when you sell your token is like who is buying it and what are the motives? Are they aligned with the project? Are they long-term investors, or are they just looking to dump immediately when you list it? And I think there's this mechanic around doing longer lockups if you want to invest at a lower price and some sort of merit based access. Can you just tell me a bit about it?
Yeah, absolutely. So what's cool about Legion, the reason we went with them as a vendor is people who want to purchase the token connect their wallet and their Twitter account. So there's a score basically to say like I'm a legit person. Smart people follow me. I'm into this. I know what's going on. I'd be a good member of the community. So there's an application process. And then, yeah, the way that we've set up the tiers is that there's a few tiers where there's different valuations for the token based on the lockup period.
Gotcha. Can you share any of the specifics around the price, like what FDV you'll be doing the sale, like fully diluted value, market cap, whatever you want to call it?
Yeah, absolutely. So the range is from, it's a pretty broad range. The range is from 100 million FDV. That has a year lockup. And then there's a sliding scale to the other side, which is a 250 million FDV, which has no lockup.
Mm. All right, that was awesome. It was cool to chat to you now after having heard about Lit Protocol with other guests before. So it's cool to hear it from the founder. And yeah, I think this is awesome. All the best with your launch. Is there anything else you'd want to share before we leave?
Yeah, I mean, I would say, like, I guess, like, one of the things that I'm looking forward to, just to maybe cast a flag out into the future that I think is coming and is at the intersection of crypto, AI, and the current kind of like economic world that we're living in is for many years people have talked about the flippening as this moment where the market cap flips where the market cap of Ethereum flips the market cap of Bitcoin. Recently, I've been thinking about a new flippening. We may be still several years away, but it's worth mentioning, which is on a daily basis when there's more transactions performed on crypto rails versus fiat rails. We're definitely not there yet, but pretty excited about the ability for agent based transactions, whether they're microtransaction based, and also just the open nature of blockchains for crypto to really be the thing that causes that flippening. And then the other thing that I'll mention, which is a little bit unrelated, um, but is just want to kind of like wave the flag one more time for collective intelligence. You know, I've talked to a lot of people in this space who are building in all kinds of things, and largely people in crypto go, the reason we need to build AI infrastructure on crypto rails is because corporations are bad and scary. And the reality is that most people in the world trust most corporations most of the time with their finances, with their data, with everything. And I think we have a responsibility as builders not to say our thing is better because it's safer, which is true, but that's not really what people care about. Uh, I think as a space, we need to kind of like collectively build and focus on and talk about our thing is better because it delivers better results. It improves people's lives, it creates better products. And at the intersection of crypto and AI, it seems like collective intelligence and the types of products that are in that category will be the thing that ultimately motivate the crypto fiat flippening that I believe is coming in the years ahead.
Super interesting. Also, the notion of AI agents causing more transaction happening on chain versus in TradFi, that being sort of the thing bringing that about.
Yeah.
Awesome. David, thank you so much for coming on the show.
Thank you so much for the time, Sohail. It was a pleasure.